Okay, welcome to the lab, or the video on how to do the solar rotation lab. If you're working from the thumb drive, at the root of the thumb drive, there's simply a solar rotation batch file that you'll be able to click on. If you have loaded this onto your PC, you'll probably have to go, that link probably won't work. You'll need to go to CLEA, solar rotation, and go down to the solar rotation executable to run the application. Okay, so the very first thing we're going to do is we're going to log in. After we log in, again, you want to get everybody logged in. It's taking a little time here. Then you say run, file, image database, image directory, load, and we actually need to go back to the CLEA lab. Okay, that it should, when you run it, it should automatically go to that a2 list.txt, and so that's the list of all of the various images. So now what I'm going to do, and just one of the things you'll find that there you can go from May through August of 2002. So just what we're going to do is we're going to start with 1700 on May 9th. Okay, so we're going to pick one image per day. You don't need to do more than one image per day. It's going to take us several days for the sunspot to go across the sun, and so no need to actually record more than one measurement a day. So I'm going to do that. I click that one, then I hold down the control key. I click that one for the 11th, 12th, don't have much choice on the 13th, 14th, 15th, 16th, 17, 18, 19, and I'm going to go up to the 28th. 20, 21, 22, 23, 24, 25, 26, 27, and finally the 28th. Okay, once I've selected the various images, I'm going to go to File, Image Database, Load Selected Images. And we can see that as it loads, it displays the images, and we can see those images, those sunspots rotating across the surface of the sun. Okay, now that we've loaded all the images, what we'll do is we'll select a sunspot that we're going to track, and we'll record its position. So we're going to call that sunspot there A. And what we do is we use the slider or the arrows to position the X. We record it as A, and we say record. And what we're trying to do is get as close as we can to the center of that sunspot. Okay. Go to the next date. Click on it. Go to the next date. So basically what we're going to do is we're going to go to the different dates and record the center of the sunspot as best we can estimate. Again, that is A. So in my data set of images, I also included recorded data on sunspots B and C, as we can as we can observe on the screen now. Okay, so the next thing I'm going to do, we definitely want to take your measurement data and save it. Okay, in this case I would already save that data, so I'm going to call it data 2 so that I do not overwrite the previous data. I want to save it in that data directory. What we wanted to do is we wanted to create on the F drive, or on the thumb drive, we wanted to create a data directory. The reason we want to do that and we want to store our information in the data directory is because if you use the default directory and your program crashes, CLEA has this tendency to erase your previous data, but if you put it in a separate directory where it doesn't necessarily know where it is by default, it'll retain your data and you can pick your data up and run with it again. So again, it's always a good idea, and in this situation we have the solar rotation data stored in the data directory. So the next thing I'm going to do here is I'm going to exit the sun display window, and that enables the analysis, and I'm going to do plot fit data. I'm going to go to dataset, load, longitude values, and now we see we've got measurement data for A, B, and C. So I have measurement data for A, B, and C. I'm going to select A, and it puts the information on the screen and starts off with a line. Now the goal here is to get this line to fit the data as best as possible. So what we want to do is we want to adjust it until it goes red and then bring it back again. Okay, so there's that initial fit, so that I'm going to adjust the slope again until it goes to a minimum or goes red. Now keep in mind that I want this fit to be the lowest possible number. What it is that's the error between the data and the line. So then I'm going to go back up here, try that, look at how much lower I'm getting it. So I keep toggling back and forth. Once I get turned red, I leave it. So that's coarse. Now I want to do fine adjustment. Okay, now I'll adjust the slope. Once it goes red, I know I've got to back it up a little. Okay, so now I check that. It keeps getting... So you have to iterate back and forth here. Now, normally you'd use a mathematical algorithm to give you this result. So now I am pretty much done with that measurement. Okay, my slope is in degrees per day, and so what I'm going to do is I'm going to divide the number of degrees in a circle by the number of degrees per day, and that will give me the synodic period of the sun, which is the measurement of the sun relative to Earth, the observer on Earth. So I go to File, Record Results, and I've computed the synodic period to be 26.582. Okay. Now the sidereal period's another beast. As we saw in the lab, the sidereal period is equal to the synodic period times the number of days in a year divided by the sum of the synodic period and the number of days in the year. That gives me a sidereal period of 24.779 for this example. Okay, so I'll just say OK. The result data is added to the list. The next thing I'm going to do is I'm going to do the same thing for A, B, and C. Dataset load, longitude values, and I will pick B. And that displays this, and I go through the process again. Okay, so as we can see here, I've recorded figured out the information for A, B, and C. So one of the first things I want to do is I want to print this window. I'm going to print it to the Microsoft XPS document writer. I'm going to save it, basically put it in my data directory, and then what I'm going to do is I'm going to go to that data directory and I'm going to load that. Now there's not much I can do with an XPS file right off the bat, but what I can do is I can go to the snipping tool, create a new rectangular snip, take the entire screen, and then I'm going to save that as a PNG file. I'm going to replace what I had there already. Okay, and I'll include that PNG file showing my A, B, and C. I will include that in my lab report. Okay. The other thing I want to do, so I'm done here with my analysis. So I go back here, File, Measurement Data. I want to view, we already saved it, but I want to view, edit it. Okay, I'm going to list, so this is going to show me all of the measurements that I did for sunspots A, B, and C. I want to say save that data as a text file. Okay, I'm going to put it in the data directory, solarresults.txt. Or I can actually, I want to do solarmeasurement.txt to take the default, but again, put it in the data directory, overwrite what I had there. So this, I'm going to take this information and include it in my lab report. I'm going to go to Analysis, Results List. There we go. These are all the results for my 3 sunspots. File, Save Data, as displayed. Put that again in the data directory. My solar rotation results text file, save that. And now what I've got, if I go look in that data directory, I've got my solar measurements, my solar results, and my screenshot. And those 3 things comprise the data that I'm going to be using with my lab report. So have fun. We'll see you later.